day 4 here, I'm starting on the second page of notes, and we're still in some similar triangles. Now, what was the rule about similar triangles? What made triangles be similar? Okay, so they had to have what about all their angles? No, what's true? What about the corresponding angles? So all angles had to be congruent, and what else had to be true for similar triangles?
Corresponding side should be.
The sides had to be proportional. And remember, all proportional means is equal fractions. So if you made a fraction out of one set of sides, it had to equal the fraction on the other set of sides. And the reason why I started with this page is this page seems to make the most logical sense to go on from there. Because if the sides are proportional, other parts are going to be proportional as well. And if you remember back to kind of the dark age before Christmas, you'll recall learning about some other parts of triangles other than just sides and angles. Remember these? We had altitudes, and we had angle bisectors, and we had medians. Remember those guys? So Candy is someone who remembers what an altitude did. Yes, ma'am?
Did it imply right angles?
Well, yeah, but like what is the altitude? What is an altitude?
It's a line
From
the angle, and it just makes a straight line.
They're all straight. Okay, you want a little help? Go ahead. It's perpendicular to the other side. So it starts here, and it's perpendicular to the other side. Well, the thing is that if there's similar triangles, it's not just the sides that make equal fractions. The altitudes make an equal fraction, and that fraction will be equal to the fraction the sides make. They all make the same fraction. So, for example, that's not math, put it away. So if I made a fraction with AB, what would be a good corresponding part to make a fraction with AB with? EF. So let's pretend I make that fraction. Since the triangles are similar, the altitudes have to make a fraction that's equal to that fraction. Which means I can give you a bunch of problems to solve with it, and you should be able to do it. Okay? Oh, look, problem number 2 is an example. Look, there's some altitudes in there. This one's 10, this one's 8. Okay? So Sarah, which fraction would you like to make out of the 8 and the 10? Would you like to make an 8 on top of 10 or a 10 on top of 8?
8 on top of 10.
So she says to do 8 on top of 10. So she's doing small on top and big on bottom. That way you can keep straight. Which ones am I putting on top and which ones am I putting on bottom? So which piece, if I'm trying to find x here, which piece on my little triangle would I have to correspond it to? Well, x is from H to I, isn't it? So what would be its corresponding piece? It'd be LK. Okay? And it's 14. Which one goes on top? The x or the 14? The 14 will, because it's on the same triangle as my 8. I did the small triangle first, and now I'm wanting to do the big triangle. Now, if I had switched this, if she had said, oh look, 10 is on the left side, and what I see first I want on top. If she had done the 10 with the 8, you could then say, well, the x goes with the 10, and that would work. You could do big on top and small on bottom, as long as you keep it consistent through the proportion. Okay? Everything has to be corresponding. And you would cross multiply, and x would come out to be something like 17 and a half. But you all know how to do algebra, so I'm not going to remind you how to do the algebra every time. But wait, there's more. We have other parts. That was altitude. Someone who wants candy, remind me what an angle bisector does, Elise.
A line that cuts an angle into congruent angles.
Yeah, it cuts cuts it into two angles that are congruent. Remember, angle bisector implies two congruent adjacent angles. So this guy, QS, is bisecting my angle. It's an angle bisector. And so is UW. Well, they are corresponding parts of similar triangles. So they should make an equal fraction. Okay? So Charles, how would you want to set this up? Do you want to do QS on top or UW on top?
UW.
UW. So he says if I put UW over QS. So he's doing small over big. Let's match that up. Okay? And it should be the same ratio as a set of corresponding sides. So I need to pick a matching set of sides. Okay, let's see. Ahmed, what's a set of matching sides that I could go with?
QP and UT.
So if I did QP and UT, since I put UW on top, which of the ones you picked would have to go on top? The UT goes on top because they're on the same triangle together. So they're both going to go on top. They were both in the small triangle. And then my big triangle guy is QP. And so again, it's just making equal fractions. These parts of similar triangles should make the same fraction. Do I have any of those down here? Number 3, oh see how the angles are congruent? So that's an angle bisector. So I've got 32 and 24. So just for giggles, let's say I threw 32 on top of the 24. So I've got a big over a small. What would be a good fraction to set up that it should equal? Probably something with sides. Yes?
38 over X.
I should have 38 going with X. Let's see if he's right. A goes with C, A to C, and so it should be EF. Yep, he picked correct sides. And which one did you say went on top? I missed it.
The 38.
He says the 38 should go on top, and the X should go on bottom, because 38 is on top of the big fraction. So we did big triangle first, little triangle second, because that was what initially was chosen. You could do this upside down and do small first, then big on bottom. Just stay consistent. Oh, look! It works for medians, too. If you have similar triangles, the medians are proportional. What do medians do? Who remembers? Yes, well,
Create a midpoint.
they don't create a midpoint.
They bisect at the midpoint.
They are a segment from a vertex to the midpoint. Okay? They are the segment there. And they should make the same ding-dang fractions as if you set up a set of sides. So, V, make me a fraction. Which one do you want on top, big or small? Big. So she says JH is going to go over NL. Okay? So big, small. So if I use a set of sides, I need to use a side from my big triangle first. So Valen, pick a triangle or a side on my big triangle. I can't hear you, I'm sorry? HI. So we're going with high on top. And so what would correspond to that? Reagan? LN. Those fractions should be equal because the triangles are similar. Ta-da! And so you go down here and you're like, oh look, I have a set of medians. And I'm going to do the guy on the little triangle first. So X goes with 15. I did small first. So if I go to set up this other one, what should I throw in? Pick a set of sides. So Audrey, pick one of the sides on the small guy.
16.
She chose the 16. Which one of these on the other guy corresponds to the 16? You say which one?
20.
Is it the 20 or the 24?
20.
It's the 20. And there are two ways you can tell. One way is that 16 is the smaller of 16 and 19.2. So I want the smaller of these guys. The other way to tell is to say this is TX 16. TS corresponds to DE. And you can tell they go together that way. So the 16 would go with the 20. You'd solve the proportion, x comes out to be 12 or something. Questions on setting these things up? Okay? Can you all set up equal fractions with corresponding stuff then?
Probably.
Probably. Turn the page. Now I'm going to put a wrinkle in things.
A wrinkle in time.
No, a wrinkle in triangles, actually. Not a wrinkle in time. Here, I'm going to focus on just one triangle at a time and not use similar triangles. But it's going to kind of act like similar triangles. Here, I have yon big old triangle. Triangle ABC. And I've put an extra piece into triangle ABC. It is segment BD. Raise your hand if you know what kind of segment BD is being. Yes?
Angle bisector.
That is an angle bisector. Because it's got the two angles, one on either side, are the same. Okay? If you have an angle bisector, see how it comes and cuts the opposite side into two chunks. Do they appear to be the same size to you?
No.
No. And they will not be unless it's isosceles or equilateral. But there's a fun thing about these chunks. This chunk on the left can be put in a fraction with the side on the left. So I can make a fraction of AD and AB. Guess what that fraction's going to equal?
DC over B.
It's going to equal the chunk on the right in a fraction with the side on the right. So when you put an angle bisector in there, it cuts you into two smaller triangles. And the big chunk and the big side make a fraction, the little chunk and the little side make a fraction, and they should be equal fractions. More equal fractions, just proportions everywhere. And so you come down to problems like these, and all you have to do is say, oh, 4.8 would go with 12 because they're on the left. What fraction would I make on the right?
X over 18.
X and 18. Stuff on the left, stuff on the right. They make equal fractions. They make a proportion. And that's, you'll end up using a calculator on that. X ends up being something like 7.2 when you cross multiply and divide. Okay? But that's not where I get evil. I get evil on problems like number 9. Okay? And I'm telling you up here in the instructions, KN is an angle bisector. For sure, it's an angle bisector. So could I mark the angles if I felt like it?
Yeah.
You could. But that's not what I'm focusing on. Since it's an angle bisector, you know you can make equal fractions. So, somebody I haven't picked on yet. Ethan, on the left, what's a fraction I can make out of these two guys on the left of my triangle?
18 over 12.
Sure, I can do 18 over 12. So he did the side of the triangle with the chunk. So over here on the right then, I would do the side of the triangle first, and then the chunk. How big is the chunk?
X minus 12.
How do you get x minus 12?
Because if part of the side is 12, then X is the whole side, then you just need whatever the side X.
Yeah, if the whole thing is x, and this part over here is 12, I need to cut off the 12 to get the length of ML. And so that's what would go on the bottom. And you'd have to know how to do this. So you would do 18 times the x minus 12 would equal the 12 times the third. Oh, it's just algebra still. You're still just going to distribute and get x by itself, and x comes out to be something like 32. But again, it's just setting out the left side stuff equals the right side stuff. Okay. Questions? And you're going to get lots of practice of this on your homework, but again, it's just about equal fractions. Notice, is this two similar triangles? No, this is one triangle cut with a median, not a median, angle bisector. But it uses the same proportionality, so we're talking about it. Let's get away from similar triangles even more. Go back to the very front now. I'm going to pretend that I do not see two triangles here. I'm going to pretend that all I have here is one great big triangle and a parallel line cutting across it. Now this does happen to make similar triangles, but we don't care about that. All we care about is the parallel line. A line parallel to a side of the triangle. That's what I care about. And when I have a line parallel to the side, that almost reminds you of a mid-segment, doesn't it? Do you remember doing mid-segments? They were parallel. Where did they cut through? Where did parallels cut on the side? Where did mid-segments cut on the sides of the triangle? In the middle. This is also parallel, but it doesn't cut in the middle. Okay, so it doesn't get a fancy name. Okay, but it cuts the side into two chunks, doesn't it? I've got a top chunk and I've got a bottom chunk. And so if DE is parallel to AC, guess what happens with the chunks that we've been seeing over and over and over again? They're proportional. So over here on the left, my top chunk, DB, over my bottom chunk, DA, has to equal the fraction of the chunks on the other side. And so I did top over bottom, so I'm going to do top over bottom, BE over BC. The chunks are proportional. Crazy! But that makes it good for you because you know how to set up proportions. But wait. There's more. Remind me how raise your hand because you can get candy for this one. If you remember how a converse works. Go ahead.
Is it flipped around?
Yeah, you can flip the hypothesis and the conclusion. So this one is going to say if the proportion of my chunks, top and bottom, equals top and bottom, if those fractions are equal, what has to be true? Yes? Then the side AC has to be parallel to the cutting piece that is going across there. You're like, hey, that's not so bad. I can set up chunks. And so, oh look, I have a triangle. Do I have a side parallel to a cutting part? You do. So the chunks should equal the chunks. So I need someone who wants to set up my proportion for me. Nobody wants you, Mia? What are two pieces that would go together?
X over 15.
So X would go with 15, and she's putting it on top of 15, which is fine. So left chunk over right chunk.
And then 14 over 12.
And so up here, she's going to do left chunk over right chunk. Could she have done right on top and left on bottom if she wanted to?
Yeah.
Sure, nobody's stopping her. But the chunks go together, and so you put your chunks with your chunks. This one, x happens to be something like 17.5. And if you want to check it, please do. I think it's correct, though. I did try and check these before we did them. You're like, okay, that's not so bad. I might give you stuff like number 6, though. So, Luke, set me up a fraction for number 6. Oh, first, do I have parallel stuff?
Yes.
Okay, so that's what you have to have before you can even start. Since I have that, what are you going to do? Do you want to do the left chunks first or the right chunks first?
Left.
So if we do the left ones, which one would you like on top, 6 or 21?
6.
Yeah, most people like it in the order they see it. So 6 over 21 over here on the left. So then what has to be done on the right?
X minus 1 over 3x plus 1.
X minus 1 over 3x plus 1. Has to go in that order because we did top over bottom. And so then you would have to be able to cross multiply. Oh, but that's just algebra again. 6 times the 3x plus 1 has to equal the 21 times the x minus 1. And then it's just algebra again. That's not even a quadratic. Do you want to bet that on the homework I will set this up in a way that you end up getting an x squared somewhere?
Yeah.
Yeah, all I'd have to do is switch where that 3x plus 1 is. If I just switch it to the other side, you're going to be cross-multiplying and getting a quadratic. And you're like, oh man, that's evil! Yes! Okay? Oh, but we haven't played with the converse yet. Let's play with the converse. Turn it over. I'm not going to, this is the whole, Chekhov's gun thing for those of you who have ever studied movie tropes. If I point it out, you know it's going to end up showing up. Okay? Here, I don't know if they're parallel. So what has to happen to force them to be parallel?
The proportional sides.
The sides have to be, the chunks of the sides have to be proportional. Okay? And so you go, okay, who haven't I picked on yet? Oh wait, I don't think I picked on you yet. Make me a fraction out of some of the sides.
Alright, so...
Do you want to do the left side or the right side?
left.
So for the left, which do you want on top, 11 or 15.4?
15.4.
Ooh, he's going backwards from how it's in the picture. He wants to do the bottom thing on top and the top thing on bottom. And so if he does that, he has to be careful. What's got to go on top from this side?
14.
The 14 has to go on top, and the 10 has to go on bottom. Well, how do I tell if this is true? There's 2 ways to do it. What's one way to tell that these are actually equal? Yes. You could just cross multiply. 15.4 times 10 is 154. Guess what 11 times 14 is?
154.
If those are equal, is this a good proportion?
Yes.
Yes. And if it's a good proportion, what ends up happening? N has to be parallel to JL. What's the other way to tell if this is a good proportion? Could you just divide the stuff on the left and divide the stuff on the right and see if they're equal to each other? Yeah, that's another way to do it too. And I don't care which way you do it, as long as you do it right. Okay? Now let's take this and extend it. Now, could these eventually go up and make a triangle?
Yeah.
Sure they could, but we're just not gonna. We're just gonna have a bunch of parallel lines cut by transversals. So I've got left transversal and I've got right transversal. And I've got 3 parallels. Count them. 3. Or you could have more.
1, 2,
See, 1, 2, 3 parallels. Okay? Guess what the rule is if you have 3 or more parallel lines cut by 2 transversals? I heard it.
They're proportional.
It's going to make proportional chunks again. So here, what's one of the chunks I make? AC. And it's with CE. Guess what it's going to have to equal? It's going to have to equal the fraction BD over DF. The fraction of chunks on the right has to equal the fraction of chunks on the left. But that only works if you have all the lines being parallel. So if all the stuff is parallel, the chunks are proportional. If the stuff is not parallel, all bets are off. And you have to do other math. Okay, go ahead. Okay. And so, of course, I'm going to find a way to make this disgusting, but it's all just about setting up your stuff. Oh, look, I have 3 parallel lines. How do you tell they're parallel? Little arrow dudes. Since they're parallel, I should be able to set up a proportion of all the chunks it's cut into. Okay, so Charles, give me one fraction in my proportion you want to make.
Could it be 18 over 45?
He's doing it upside down just for giggles. He's doing the 18 on top and 45 on bottom. Could he have done 45 over 18? But since he did 18 on top, which one has to go on top from the other side? The X has to go on top, and the 52 has to go on the bottom. So just make sure when you're setting up your proportion that you put the right chunks together with the right chunks. And you could cross multiply that and do all the things, and X would equal 20.8. Okay? But it's all about setting up a proportion. This is not similar triangles, but since it uses the same kind of setting up of proportions, we're throwing it in with them. Okay, I know you're thrilled. But that's all, wait, stop. What do I do on number 13? I've got 31.5, and I've got X on bottom, and then I've got a 28 on top, but I don't have a chunk on the bottom that I know how big it is. So how am I going to set this up? I don't have a number down here.
You subtract 92 with 28.
Oh, I have to know how to subtract. I know, crazy. 92 minus 20 would be 72 minus 8 would be what? 64? Something like that? That wasn't a guess. That was me trying to calculate. It is 64? Yes! And then you'd cross multiply and stuff. So yes, I do expect you, if I don't give you a piece, to figure out what the piece is. Okay, because you should be able to solve every single one of these. Okay, well, my friends, that is the end of the notes. It's all just setting up your proportions.